Pre-statistics. Using elimination to solve systems. Lesson objective. Use elimination to solve systems of linear equations. Lesson objective. Example 1. Solve the systems 4x minus 5y equals 3, 3x plus 5y equals 11. To solve this by the graphing method, we would have to change both equations into the y equals mx plus b form. Quite a bit of work. To solve this by substitution, we would solve for x or y in one of the equations, and we see no coefficients of 1. So even with substitution, it's going to be a little bit of work. But this is a special case where if we were to add these two equations together, the y variables would cancel. So we would have 7x plus 0, because the y's would cancel, equals 14. So we have an equation that only has one variable, x. And if we solve for x, we see that x is equal to 2. If we substitute 2 in for x for either of the original equations, we can find y. So if we use the first equation, we have 4 times 2 minus 5y equals 3. So this equation only has one variable, therefore we can solve it. So we're left with 8 minus 5y equals 3. Subtract 8 to both sides. We have negative 5y equals negative 5. And dividing by negative 5, we see that y is equal to 1. So the solution is 2, 1. Remember, we always put the x coordinate first. To verify that 2, 1 is a solution, it needs to satisfy both the original equations. So for the first equation, 4 times 2 minus 5 times 1 should equal 3. That becomes 8 minus 5, which is 3. So the left-hand side equals the right-hand side. It checks. For the second equation, we have 3 times 2 plus 5 times 1. That should equal 11. Multiplying before we add, we have 6 plus 5. And of course, that equals 11. So we have verified that 2, 1 is a solution to this system. Example 2. Solve the systems. Now in this case, if we were to add these two equations up, the x nor the y cancel, so we can't add the equations as they are. We must add the left side and then add the right side to the equation so that one of the variables will be eliminated. So if we were to take the first equation and multiply it by negative 2, this would become a negative 6x. And a negative 6x plus 6x is 0. The x variable will be eliminated. Now we can't just multiply one term by negative 2. We have to multiply all the terms by negative 2. So if we take the first equation and multiply everything by negative 2, we have negative 6x minus 4y equals negative 36. We're going to add that to equation 2, and the x terms will be eliminated. So this becomes 0, this will become a negative 9y, and this will become a negative 27. So now we have one equation with one variable. If we divide by negative 9 to both sides, we see that y is equal to 3. Substituting 3 in for y for either equation, and in this case I'm going to use equation 1, we want to solve for x. So we have 3x plus 6 equals 18. Subtract 6 to both sides, we have 3x equals 12. And of course x is equal to 4. So the solution is 4, 3. So let's officially define the process of the elimination method. Using elimination to solve a linear system. Process. To use elimination to solve a system of two linear equations. Number 1, if needed, multiply both sides of one equation by a number, and if necessary, multiply both sides of the other equation by another number to get the coefficients of one variable to be equal an absolute value and the opposite sign. And that way, when we add the coefficients, it will be 0. Number 2, add the left side and add the right sides of the equation to eliminate one of the variables. Number 3, solve the equation in one variable found in step 2. Number 4, substitute the solution found in step 3 into one of the original equations and solve for the other variable. Let's do an example. Example 3. Solve the systems 4x minus 3y equals negative 3, 5x plus 2y equals 25. So in this example, the coefficients are different. So if we want to eliminate the y term, this coefficient's negative 3, this coefficient's 2. So if we made this a negative 6 and we made this a positive 6, we could eliminate the y variable. So we need to multiply the first equation by 2 to make it a negative 6y, and then we need to multiply equation 2 by a positive 3 to make the y term 6y. So the first equation will become 8x minus 6y equals negative 6. The second equation will become 15x plus 6y equals 75. Now when we add the two equations up, this is going to become 23x. This is eliminated. We bring down our equal sign, and then this will become 69. Solving for x, we divide by 23, and we see that x is equal to 3. We substitute 3 in for one of the equations. In this case, I'm using the first equation. We have 4 times 3 minus 3y equals negative 3. We subtract 12 to both sides and divide by negative 3, and we see that y is equal to 5. So the solution is 3, 5. Thanks for watching.